Hello guys, this is Johan Forsblom and welcome to my isometric game tutorial part number 7. Today we're going to cover terrain generation. Sorry about that. Terrain generation, basically hills. So I'm going to show you what that looks like here. And drag this over for you guys. You can see here as well. Here it comes. And here we have the terrain here, generated. So this is generated using Perlin noise, basically. And there's the guy walking around. So as you can see, when you're walking diagonally, it looks like he's walking up the hill and so forth. But basically, it's all the hills are just drawn in the background. So we don't have 100% fix for when you're walking up a slope. His Y position should move up a bit as well, but it's a good illusion still, as it is. But this is what we will be making today. And for starters, we're gonna have a quickly look at some web pages here. I had to go and use the Wayback Machine to find these old gems. Basically, these are very good articles that describes how it works, what it is, and so forth. And there's a library called libnoise. We are not going to use this library. We're just gonna have it here so you can look like what octave means and Perlin noise. What it is a type of coherent noise that is a sum of several coherent noise functions of ever increasing frequencies and ever decreasing amplitude. So then you can see, okay, what is an amplitude then? Amplitude basically means the maximum amount, the maximum absolute value that a specific coherent noise function can output. And what is a coherent noise? It's a type of smooth pseudo-random noise. And what it means is that this is a 1D noise. So you can see here there's just random points between 1 and 0. And if we look here in the introduction to noise functions, this is written by Hugo Eliasson. It's an old page that I was referring back to in 2011. This is from 2012 basically. So the site is not accessible anymore. It doesn't exist. So you have to use the Wayback Machine. I will have these links in the source code for you to look at. So here you can see this is a nice smoothed out curve here. It's an interpolated curve between dots on a graph. So here you have just random noise dots. And here you go, and it says that by smoothly interpolating between these values, we can define a continuous function that takes a non-integer as a parameter. So a non-integer basically is a slope between 1 and 0. And you have some definition of sine wave, and this is a noise wave. So basically what you see when you look at this curve here is, oh, this is mountains basically. So, or a pattern you want to have. So, and you can create many different you can actually stack these different curves on top of each other, and you will get, this is the result or sum of noise functions. So you can create like different clouds and many different things together. So but I will have these, this is also by math, I don't know, Zika or what, I'm not gonna say sucker because it sounds, well, doesn't sound very nice. So I think it should be like Zika or something like that. So he describes the math behind it here as well. So I'm gonna leave these things to you. But just a quick look in the glossary. So we would have a persistence as well, and what that is, it's a multiplier that determines how quickly the amplitudes diminish for each successive octave in a Perlin noise function. So these are the different definition, and the octaves are one of the coherent noise functions in a series of coherent noise functions. So an octave means that it's one of these guys when we are generating. See, where did we have those things? Up here, I think. Yeah, this one of these boxes here is an octave basically that you're combining to get the to get the noise basically. Yeah. Okay, that's a little bit of a quick introduction to Perlin noise, and this side here has some code as well, some functions here. So, and I found a C library for this that is just lightweight and nice, or at this place here. This is Zin, or wherever he calls himself, Z-I-N-N. So it doesn't really say much, just a make file, and the readme, just the Perlin noise library in C. So there's no specific stuff here that says if it's MIT license or wherever. So it's here, and I mean, if we look upon these things, like the raw noise here, this function is actually identical to what we have here in what we have right here. So this code is basically based upon this article here. So instead of int noise, it calls it raw noise. So we're gonna use this code for our Perlin noise. So just a quick C and a H file. So we're gonna begin. First of all, we are gonna delete some old stuff. We're gonna comment out our bit font stuff we used before in the last tutorial, from the tutorial number 6. So we're gonna remove that stuff now, and I'm gonna go to our ISO engine map here, and we're gonna create a new file. Create empty file, yes. ISO engine, and we're gonna say that's gonna be Perlin noise .c. Okay, and I'm gonna get them get the links for you here. Here we go. And I don't think we have. We're gonna add this one as well. I didn't put it in there, so we're gonna add like the lib noise glossary thing here for you guys as well. So you will have this page here in the source code as well. Lib noise. Okay, and then we are gonna save that, and we're gonna get the code from the Perlin C noise code here. We're just gonna copy and paste this stuff here, because we're not gonna write it all ourselves, as I usually do with all other code, but I think we're gonna save a few minutes by doing this. That's a C file. We're gonna add the H file as well. Add empty file, yes. ISO engine Perlin noise.h. There we go. Go back and get the H file. There we go. So we have the Perlin noise in place now. What we will do now is, I'm gonna bring this up as well. The first thing we're gonna do is we're gonna create a block terrain. It's gonna look like this, and this is just every single height of the terrain. And I'm gonna show you the tile set, how things are set up. This is a clean tile set, and we can add the numbers here as well. Or this is the block outline, is just to make this lines here around the edges. So on tile number 16 here, as you can see, or not see, basically this is the tile set that I set up. And when we are drawing the map, we will use the bitwise method to draw tiles on the screen. I'm gonna show that in a while, but first of all, we will make a block terrain with Perlin noise with 6 different levels, basically, because we have 6 different tile heights here. So as you can see in the tile set, each row of the tile set is a tile height, and this tile height is going to be equal to the height of of this guy here. I'm gonna grab this one. For some reason that didn't work out great. Anyway, we're gonna take this top tile here. And this height. Move it down here. The last row you can see here is gonna be filling up to that tile height, basically. In the tile set, so that's what it's about. So the first thing, we create a block terrain, and the second thing is that you can see there's one little tile down here, tile 16, that is being removed here. So we're gonna delete single tiles, and I can show the reason for this in a second. And after we've deleted the single tiles, we're gonna do bitwise drawing to get like the terrain look like this. As you can see, we have artifacts here. And these are the inner tiles that we have to remove later. And without deleting the single tiles, we will have artifacts like this. So the reason why we delete the single tiles is because we want to get rid of artifacts in the drawing. So that's why we delete those guys that are sticking out. And after that, we will add the inner tiles, the inner corner tiles here. So it looks like this now, and the final result will be like this. That's all the steps. So the first one is to create a block terrain, basically. So we're gonna go into our isomap here. And we are gonna create our terrain. First of all, we're gonna need a noise map. We can start by actually including the Perlin noise.h, so we can have access to our files. Find implementation. Here we go. And in here we are gonna say that we want to have float noise map, size of float multiplied by the isomap, map width multiplied by isomap, map height. So we will have a noise map that will cover the size of the map, basically. And if the noise map is null, if memory allocation failed, allocate memory for the Perlin noise map. Write to log. Just go copy this guy here. As generate map, and could not allocate memory for the isometric map generation. And I'm gonna say run noise map basically there, so we know exactly what's wrong. Run log.txt, and throw that out there, and we return out of the function if there's something not going on, something that's working right. And then we will generate the Perlin noise map here. We're gonna write a new function for this. Static void generate Perlin noise map. This guy will take in float noise map. You can also use isomap t. We're gonna get the x and y. We can have a purlin value as well. Purlin, this is like height value or I'm also gonna write out what the max height of the map is as well, just to the console, I think. And I'm gonna see, we can copy the X and Y stuff here. Just gonna loop over the map. Loop over the map. Purlin height value is going to be equals to the P noise 3D. And these are values I had to play around with just to get something nice going on before. So that's a good thing when you test the things before you start coding. It's a lot easier. We are also going to add int purlin seed here. I'm going to throw in that as well. So we have a seed for the map to generate. And we're also going to throw in a terrain height value here. Basically. We can also have a float value here, just to recalculate the thing. We can, it should be an int, I think. It's better we're gonna typecast that to value equals int, typecast the value for the purlin height value plus 1 multiplied by basically this is not going to be the terrain height, it's going to be a truncation of the terrain height. I'm going to show that to you later. Truncate terrain height. .5. And the good thing about this is the way the purlin noise function works here is that if we multiply the truncate height, this is basically the same as saying it divided by 2. If you multiply something with 0.5, it's going to be divided by 2. So if you divide this by 2, the value will actually have the height of the terrain. Say if you have the terrain height is 20, if you multiply this with the value here, you're going to get the maximum value 20 basically. So I'm going to say value less or equal to 0. The value is going to be 0. So we're going to keep values within range. Keep value in lower range, and we will have if value is larger than the max height, max height equals value. Keep the highest height value. And now we will store the value in the noise map. Isometric map width plus X. This is the classic formula for mapping values to X and Y within a single array, basically. So you calculate how far in we're gonna go, and plus the number of x values into the map. And once we're done, we can go printf. Map. Here we go. Gonna add this function up here. Gonna make sure that everything is building correctly, so we didn't do too much bad things here. Perling, what kind of Perling noise map? So generate Perling noise map. Here we go. We should add a check for the ISO map here as well, so just to make sure that everything is okay. Make sure the map exists. Throw this guy in here. Error function generate ISO map. It's null. Parameter ISO map is null. That should be good enough. ISO map, we have our noise map, and we have our Perling seed, and we gotta throw this guy in here as well. Perling seed. There we go. And what we have to do now is, because this is not gonna work right out of the bat, because well, if we are throwing in here. Yeah, we forgot about the terrain height as well. Here we go. Terrain height, and I'm gonna throw that in here. So this is a value of how much terrain height we want to have, the maximum height in the terrain we want to have. So we throw that guy in there as well. And the problem is here, because we only have 6. Okay, I think I gotta go check the kids here quickly, so I'll be back in a few seconds. Okay, back. Yeah, I'm gonna show you that right now. So we have our terrain here. And we only have 6 levels of terrain. So if we say that the terrain is 20, there's not going to be any tile to draw basically, because we only have up to 6 rows here. So what we want to do is want to map the terrain to the terrain height. So if we have 20, we want to map the highest point to 20 and then go down to get those things working there. So what we will do is write a new method. So you can throw it in here. Static void. Rewrite. noise map terrain height. Isomap T. Float noise map. And we're gonna throw in int truncate terrain height here as well. X, Y, and value. And we're gonna loop over the map. We're gonna copy our nice loop here. Loop over the map, and we're gonna get the value from the noise map. We can just copy this guy here, like so, and then we will remap the value, height value, to maximum. The reason we do this is so that we can actually determine how much of the terrain that should be visible, how much, basically how many, you can call it islands, or how many rather hills you want to have, how high they should be all around the place. So we can play around with that in a few moments here. If the value is equal to the truncate terrain height, we gotta write this on single lines, it's gonna be easier. But it's gonna be equal to 6, we're gonna clamp that up. Truncate terrain height minus 1. We're also going to keep that to value 6. Two, 3, 4, 5, 6. 1 too many. Else it's just going to be value equals 0. So we are mapping the terrain now. We are rewriting all the values, and setting all other values to 0. So, so how can I show you this in the best way? Not sure if Krita is answering me. It's not. Seems to have crashed. Close window. Sometimes things don't go the way you want to. So we gotta wait a few seconds because I want to show you what I'm talking about with some drawing as well. Loading bundles in Krita. Should probably update the program. It's been a while since I did that, but it's gonna work properly, I think. Anyway, we are remapping the terrain here. It's gonna be sure that. Of course, we're missing the semicolon here all over the place. Build conflicting for isomap. Yep, there should be a conflicting statement for that. Yeah, and we have zero, and let's put terrain height to 20 for starters. Build. Good, thank you. And we're gonna go back to isomap. We're also gonna rename this guy here to, it's not an empty map, it's gonna be a new map, basically. So we're gonna go into the H file as well for the ISO engine here. Create new map. And in here we will find the empty map, and we will rename it to, oops, new map. That's a better name for it. Discard all. There's no drawing there. And here we go. Here is Krita. And hopefully use this template. And of course the pen is to be changed as well. Yes, please. Monitor setting, we want to use this guy right there, yeah. Not sure if the pen is working now. Well, we can draw with the mouse. For the moment, we're gonna probably have to reboot the computer because it was in sleep mode and stuff. So it's not the best when things like this happen. And we need to have a bigger size pen. That should be okay. So basically we have our terrain height. It's really hard to see the pointer. So that's good enough. So we have say we are generating our terrain right here. Making a better curve. There's something like this, and the scale here. Here you go. This is 0, and this is now going to be 20. We are remapping this to between 1 and 20. And up, say here is like where the level for 6 is coming. That means we will only draw like the values that are below here right now. But what we're doing is we're saying that what's better if we do like this. 20 comes along here. And here you have like 15. So we can fit these guys in. So right now everything that we have 6 levels down here. Not really proportional to what we're doing, but this is a terrain we have generated, and it's all, and the 20 is on the tops here, basically. Here. So what we want to do is we want to remap these values here. So 20, the maximum value becomes the maximum value of 6, which is like our top value right here, the 6th tile down here. So that row. So we want to remap those. So, and when we continue to map these things, we have 20 and 19 becomes 5. And so forth, and 18 becomes 4. So we are remapping the values of this terrain to fit within the height values there. So let's see if everything goes as planned. I hope so. We're going to take our rewrite noise function here at the top as well, and we throw it in here. And after we generate it, the map, we can say ISO map and noise map and terrain height, basically. Now we want to draw this map out as well. Going to comment out all the old code here. Check my notes quickly to make sure we get everything done. Okay, we're going to write the static void draw Berlin noise terrain. the isometric map, and we're gonna need the noise map as well. What else do we need? I think that should be it. Yep. We need the X and Y as well. And of course the value. I'm gonna copy our nifty nice for loop. Or rather 4 loops. Multiple of them, I mean. Here we go. Noise map. Map width plus X. Get the value there. And now we're gonna say isomap set tile at on the isomap and on the X and Y. Layer 0 and value is gonna be 1 plus. Now we're gonna define a new value here. Unless I don't think we have it yet. Nope. Define num tiles per row and tile set. And that's gonna be 23, I know, because we had 23 right here. 23 tiles on one row here. So if we change that sometime in the future, we'll have it defined in here. So you can play around with it. And now we're gonna say num tiles in row plus the value. We get the value from the noise map. We're gonna get the value from noise map plus 15. Why 15? Well, because the 15th tile in the tile set right here is going to be the 16th tile. Why? Because we are adding 1 here, 1 plus. Why are we saying 1 plus? Well, it's because we are skipping the first one right here. So the first row here, which is basically going to be mouse pointers and something else that we can use for that, is just saying 1 plus this, and then because we will end up here with the tile number 16 here, which is our blocks. So that's just, you remember in the beginning, that's how we're going to draw the blocky terrain here, like this. So this is the first step we're doing now. So we're going to draw that. I'm going to copy this guy up here as well. And we're going to throw it in into our generate map. And let's have a build and see if things are going as we want them to go. Build and run. Just gonna make sure we... Oh! Gonna remove this guy here as well. Build and run. I can tell you the map is very blank right now. So I'm gonna have a quick look at what's going on. So I'll be back really shortly, real quick here. And the reason we're not getting anything on the screen is basically because I have not exported the file here, so we can keep the numbers at least. See here, we can put in that guy here, and we can go into the data, and we can overwrite the ISO tiles here. Export or replace? Export. Cool. Let's try this again. And I'm gonna pull it over. Okay. And here things are being drawn. So what we should do next is just basically draw the ground all over the place. It's a last thing here to make it look a bit better. And we can also remove the trees temporary. They're just being placed at random now, so you can put this to 0. And we're gonna get some ground going as well. See here, it's in the ISO map. Here we go. Static void. Draw green grass. Basically, this should be changed in the future when we're doing multiple terrain types. I'm gonna get the nice loop here, loop over the map, and we're just gonna throw in one single value here. And we have to also have to make a check here. Value is equal to ISO map get tile. We want to make sure that we are grabbing ISO map X, Y, layer 0 if we are drawing on, and if the value is less than 0, then we want to throw in the ISO map set tile here. Oh, we need to pass in ISO map. That's why it's complaining that they're, well, I'm not getting any intelligence because of this, so let's fix that up real quickly. ISO map, good, and we're gonna go and put it on X and Y and on 0. We're gonna put in tile 1, I think is the right one, because in our tile set here, tile number 1 is the grass tile. 0 is this one here, and number 1 is the green one in the beginning here. So we're gonna fill that in. So afterward we can just throw this guy in here, and we will have green grass all over the place. Too few arguments. Value 0, and it's going to be layer 0, value 1. Okay. And now we are drawing stuff here. So we got numbers for the tiles as well. So we are working, and then the next step is we're going to remove this guy here under the mouse, the single value here. Delete single tiles basically from the map. We have our little road map here. So we've done the create a blocky terrain, and now we're going to do delete the single tiles here. So I'm going to throw this guy up here. Static void, delete single tiles. ISO map, int layer, and float noise map. Like so. And this is where things will get interesting, because we need I can just get the skeleton done here. Num empty. Num empty neighboring tiles. And we need a loop for the train height. And the value. And we're gonna get our trusted loop here, as usual. And we're gonna add a new define here. Define num tile level per layer. And what I mean with this is that's not the equal sign. What I mean by this is actually very simple. We have our here. We have 6 layers for each layer. 6 levels of tiles. So we have 0, 1, 2, 3, 4, 5, which makes we have 6 levels of tiles here. So that is the definition of a layer, and we know that this height here maps to this height up here. So I'm gonna continue here with the code. And here we're gonna loop over all the terrain height, and it's gonna be equals to num tile levels per layer, and we're gonna go terrain height. As long as this is larger or equal than 0, then we're gonna go terrain height minus minus, or rather minus minus terrain height. And now we're gonna need to write a new function here, which is going to be called static void tile is within terrain height. So we're going to check is if a tile belongs to a certain height here, a certain height of in the tile set. So that's what we're going to write, and it's going to take in two values basically. Tile value and terrain height. Min tile value, terrain height multiplied by num tiles per row in tile set minus 1. And the max tile value is going to be equal to min tile value plus the num tiles per row in tile set minus 1. So we are setting the range here for a tile. Even if it's within that range, we know that it's part of the tile, part of that terrain height. So tile value is larger than equal to min tile value, and tile value is less or equal to max tile value. Then we're going to return 1, and if not, we return minus 1 here. Cool. Good, we forgot a semicolon there before, so now we got that thing straightened out. I'm gonna check my notes here as well. Where is that in my notes? Very strange. Sorry about this, I need to get my code to the right place. Tile is within terrain height. Yeah, this is one we want. Now we can just write a quick comment here. Function checks if a tile is part of a terrain height in the tile set, and each row in the tile set is equal to a terrain height. Like so. Okay, back to this place here. And if the value is of the current terrain height, drain up, we are drain. If the values of the current terrain height, yeah, that's because we are looking there, so we can just check it here. If tile is within. Okay, that's not the correct spelling here. Within. Now we're just going to throw in the isomap, the XY, and okay, I forgot to do that. This one needs more isomap get tile, of course. Here we go. Isomap XY and layer. I'm going to compare this to the current terrain height. That's what we're going to do. And if it's larger than -1, if we know that it exists. If it is, then we know we have num empty neighboring tiles is equal to, and now we need to write a new method, and not a method, but a new function here. Static void count number of neighboring tiles. So I can show you here in the screenshot here. We have over here. Yeah, here. So this tile right here, you know, paint on it is my thought at least. Well, we just want to have a pencil that works. This tile right here. So we're gonna check is if this one has more than one connecting tile, then we know. So if it has less, if it only has one connecting tile, in this case it's just one here, we know we can delete this one. So that's the check we are writing now. So we have to count count how many neighboring tiles we have. So we, and if it's less than one, or if it's just one tile, then we can delete it basically from the map. And the reason for this is when we are doing the bitwise drawing of the map, we will get artifacts, as I showed you earlier on. So I have right here, we draw strange things that we don't want to have on the map. So I'm gonna correct that. I put that to -2. And we also need to get the terrain height in here that we are checking on. And if the terrain height is out of bounds, we just return. Ah, 0, of course. And we're gonna get the tile value here. It's gonna be equals to get tile. I'm gonna get the ISO map, and we're gonna get map. Well, it's gonna get X and Y because that's what we named the parameters. And here we have to check up the tile above, up. It's not empty. Maybe the layer. And we're also going to do the F. Tile S within terrain height. Tile value. Comma terrain height. Not equals to -1. Or we're also going to check above. Terrain height -1. Sorry, +1. We're going to check below to make sure that it's not -1. Let's see here, what are we doing wrong? There we go. And this should be one parenthesis too many there. We can say the value ++. So we're checking if the tile on the same level, if it is there, or if the tile below is there, we will increase the value. And we're gonna have a look at this afterwards to see why we're doing this. Here we go. Up. To the right. So basically, when we are doing this, we're checking, say if we are here on this tile here now, the red marked, we're checking up, that means it's this tile here. And then we're checking right, and we're checking down, and we're checking left. Those are the 4 directions we're checking to see if there's any neighboring tiles, because we don't care about the diagonals right now. That's not gonna, you don't have to count them for this algorithm to work as we want it to. Why did I change that up there? This is where I want to change things. Tile to the right. It's not empty. And it's going to be X +1. I'm going to check below as well. Below is not empty, and it's going to be Y +1. I'm going to check the tile to the left. -1. And then we're going to return the value. I don't think we're using tile value here even. Yeah, we are. Just setting it to -2, doesn't matter whatever it is at this moment though. We return the value, because that's what we are counting here, how many tiles there are next to our place. Return value. I think that should be it. Let's go and have a build and see if I missed anything. Return without a value. Yeah, static int probably is what we want to have there. build. Yeah, semicolon is missing. Yeah, we haven't finished this guy yet, so we can just go build to see if everything else is alright. Yep, enter as well. Throw this guy up here as well, so we have the prototypes ready, running. And here comes my daughter, so I have a quick break here. Let's continue here. And build. Cool. Count neighboring tiles, yeah. Here we go. So num empty neighboring tiles equals to isomap here. X and Y count number of neighboring tiles. And the layer, and we're gonna get the terrain height as well in there. And if num empty neighboring tiles is less than 2, that means that is 1 or 0. You can say the value is equal to isomap get tile isomap xy and layer. Then we're gonna say isomap set tile isomap xy layer comma value minus num tiles per row in tile set. So what we are doing here now is we are taking this tile, this right here, this guy here, and what we're doing, we're simply pushing this one down one level. We're rewriting that value to be a flat value right here at the same level as the level below. So we're pushing it straight down. So that's what we are doing, looping over these guys here. Build. So if we run this first now and have a look, first of all, we're gonna change the mouse speed. I think it's gonna look for speed here in the code. Oh, sorry. Speed. We need the map scroll speed, yeah. Somewhere we are setting that 300. Let's put that to like 1200 instead, because we want to have a faster moving mouse on the screen. So if we first take a look here now, down here, that's the guy, 16. We're not using this method right now. So let's see what happens if we throw it in. Delete single tiles, and did we add it up here? No, we did not. So we're gonna throw it in here as a prototype up there first, and we're gonna go down to generate map, find implementation, and we're gonna do this. Gonna check my notes as well where we need to put this guy. Put it in here. Delete single tiles. I'm gonna go put it on the isomap. I'm gonna put it on the layer 0 and the noise map. Here we go. And from my experience when I was playing around with this, we're gonna do this 2 passes of this, because sometimes when you delete the tile, it's gonna be another one there. So 2 passes of this will sort out all the irregularities, basically. So if you bring this guy in here now, I'm gonna just get the window here. And as you can see now, the tile is gone here. So we have now removed that tile that was in the way for our generation to work. So next up is the bitwise drawing. So this is what the result we're gonna have now after we have written the bitwise tile drawing. And we're gonna go and have a look at a web page here. And This is from Wayback Machine as well. This is the article that I originally used to do this, to learn this back a couple of years ago. And there's another one here, which I think is also good here. AngryFishStudios.com is describing this very well as well. So this is the original article I used, and they are describing different things that you can take things further by removing error and adding greater variety to things by using trinary counting systems and stuff like that. This uses a different approach here, where you can move everything to 8-bit and use 8-bit stuff instead. So if you have 64 tiles, I think it's different, 48 cases here as it says. You can simplify from 256 cases to 48 cases to build a tile map if you want to have like more things happening. But we're just going to focus on the simple part now, and it's going to be drawing. Sorry about that. Drawing the tile map here. So what is bit mask drawing? Basically what you see here, step 2 bit mask, is you have 1, 2, 4 and 8. So when you're doing something, just bring out Krita here. I can delete everything in here, and we can draw with my trusty mouse. Yeah, so what it's all about is if here's a tile that you are checking right now, this is empty. You can just draw some ugly tiles here. This is not going to be your awesome preparation thing. So here's the tile that we're checking right now, and if there's a tile above here, that is like, I'm gonna put something in here. No, we're not. But say there's a tile up here. That means, according to, let's see if we can do like this instead. Well, that didn't work too much. Great. Let's see here. We can move this guy here. Whoa, the mouse just completely disappeared there. There we go. And we can go into adventures here. So it's describing things here. So if we have a value in the top here, if there's a tile here, you can add a 1 to it. So you see here, that means the tile is just 1. And in the tile sets, this is a 1 right here. That means this is mapped to 0 and this is 1. So what's going to happen is that tile 1 is going to be represented here. So, but if you have 2 tiles, say you have 2 tiles neighboring, and this will give you 2, 4 and 8 is the values here, the tiles. So if I'm surrounded by all these tiles, then we're going to have 8 plus 4 plus 2 plus 1. So you can see that value is going to turn into 15. And if we check 15 in the tile map, it's this filled one down here in the corner. So in this tile map, it has mapped all these things. So if there's 4 neighboring tiles all around, it will be this filled one. And say if we are only having 1 and 2, these two here, only those 2 values are going to be value 3 in the tile set. So that means 0, 1, 2, 3. It's going to be this guy here. And right now we don't have that as an example here, but we can take 4 here, for example. He's checking the tile up here, and he has a tile down below. That means it's going to be a 4. So 0, 1, 2, 3, 4. So that guy here, it's going to be 4 because he's checking this tile here. And then we have number 4 there. So I hope this tells you what's going to happen. And he has laid out all of these to see what kind of binary values they get down here. 7, 8, 9, 10, 11. And also the decimal value here for if 2 neighboring tiles are there, it's going to be number 12. And so forth. So you can build a tile map very easily by using the system. So that's what we are going to do. We will be using bitwise tiling to do our nice drawing. I'm gonna find my implementation here that I did earlier and type it up for you. Okay, so static void. This will be called auto tile. terrain. I'm gonna bring in the ISO map and the layer. Layer, there we go. Now we're gonna do some looping as usual. See if there's a nice setup for that. Very good. We need XY value. We're gonna need like an paint tile. And we're gonna need a terrain height. That's gonna be equal to we define that and just don't remember it in the top of my head right now. Num tiles per layer, that's what we want. Here we go. Loop over the map, basically, and we're gonna loop over the terrain as well. Just copy this guy here. Well, we don't need to do that. We can just initialize this to 0 just to get that in here. And there we go. And yeah, we need to get these guys out. Cool. We're gonna loop this down and gonna check if the value is of the right terrain height. That's the first one we check, because we don't want to do a bitwise drawing on a different layer. Sorry, on a different terrain height than what we're checking here. Iso map get tile. We want to get the tile. We're going to say iso map, and we're going to get the XY, the current layer we are working on, and the current terrain height. Here we go. Terrain height. We'll make sure this is larger than -1. And if that is so, we will set the paint tile is equals to. And now we're going to need to write this bitwise method. It's very, very simple actually, the bitwise tile drawing, because all we do is just add up the numbers basically. So static void. Gonna call this bitwise calculate tile. Good name for that one. And iso map T, and we're gonna get the iso map as well. And we need int x, we need int y, and we need int layer, and we need the terrain height. And this guy. Int value is going to be equal to 0, and we're going to need int tile value as well. Equals to 0. I'm going to check that the terrain height. If that is less, we make sure terrain is within lower bounds. Return -2 if it's not. We can need, okay, it's going to be static int, of course. And I'm going to get rid of that. Then I'm going to get the tile value. Tile value is going to be equal to iso map get tile. And we're going to get it from the my app, from the x, from the y, and from. Now what we're going to do, we're going to check up first. We can just copy this other guy here. Basically everything here is the same, almost the same. Yes, see if the terrain height here is larger than num. Here we go. We can also add like the mine, or if terrain height is less than 0, then we're just gonna bail out of that method and not do anything. And here comes my daughter, and I'm gonna set this for the pause for a while. Okay, and where were we? We were, yeah, adding that stuff up there, and we're gonna go back to down here again. And this is gonna look the same, basically, almost the same, but we're not gonna get. It's a little bit of a difference here. We're gonna check the same things, but it's gonna be larger than -1. Because when we check if the tile exists there, and we have to do this on the lower level, check one level down as well to add the value there. And let's see here. Oh yeah, I promise we're gonna check this stuff out before we were doing anything else. I'm just gonna finish this now as I have it. Plus plus, this should be plus equals to 2. And this will be plus equals to 4. And this will be plus equals to 8. So we're doing this. Let's get this one up here again. Because the bit mask here, if you look up, we're gonna add 1. If you look to the right, we're gonna add 2. If we look down, we're gonna add 4. And if we look left, we're gonna add 8. So that's what we're doing now. We're gonna check all this. Sorry about that. All these nice values. So 1, 2, 4, and 8 here. I'm gonna check, make sure these guys are lower than -1 instead. Like so, and we're just gonna make sure everything is building nicely. And tile value, yeah, because we need to set that to a better. Okay, so we can fix that up here as well. Quick, I should probably be doing our search and replace instead, but we're almost done here in just a few seconds here, so it's okay. And down here we have the tile value as well, running around. There we go. Build, let's see what's going on here. Yeah, we're missing some stuff here for the auto tile terrain, of course. But we're gonna have a check here first. As I promised, the single tiles, if we remove these guys here from the equation, if we take this guy out here, just do like that. Go build and run now. We're counting neighboring tiles. It's gonna do a good job anyway. No, it's not gonna do a good job. I'm gonna show you what is happening around here. As you can see here on the edges here, if we're not checking down, it's gonna delete tiles here at the edge. You see here, it's gonna delete tiles here on at the edges here. So it's not going to be as pretty. So it's going to do things wrong, basically. So we are checking one level. If it's there as well, we will add a value to it so that it will draw correctly. So that is why we are checking here the terrain height below as well. Because if it's there, we don't want to delete anything. So that's what. Why we are adding these guys to check one layer below as well. Sorry, yeah, one layer of terrain height below. No, sorry, upwards. So that is the reason. Just kill that process. Okay, let's get this auto tiling running as well. bitwise calculate tiles. We're gonna add these guys up to the top of everything as well. Auto tiles, right? So we're gonna add these. Nice. Nice map. I'm gonna add the X and the Y. I'm gonna add the layer, and I'm gonna add the terrain height here as well. So we're getting the paint tile, the tile we want to paint. We're calculating which tile we want to paint, and if the paint tile is larger than 0, you want to paint it. Set tile. I'm gonna go ISO map here, and I'm gonna go X, Y, layer, paint tile. Now we're gonna go +1, so that we skip the first the mouse cursor in the beginning, as usual. The guy here. There you go. Num tiles per row in tile set multiplied by the terrain height, so we get on the right right place there. So let's see if this guy will work nicely. Fine. What? That was really strange. Anyway. Gonna find my notes as well. Where are you hiding? Yeah, so we're gonna throw it in right here. Auto tile terrain. I'm gonna put this on layer 0 because that's where we are drawing everything right now. Build and run. I'm gonna pull this over for you guys so you can see as well. Here we go. Now the terrain. Okay, zooming in our some things. I really gotta fix the mouse zooming. It's gonna zoom to the mouse cursor basically. So this is what it looks like. You see these edges here. So as I described earlier, this is for because we don't have any inner tiles checking. So we're gonna add all those tiles to draw those things nicely as well. And for this, we will go and write ourselves some new stuff down here. And we will call this static void auto tile inner tiles, or inner corners basically. Inner corner tiles. Throw this guy in here, and we need X, Y, and value. I can just basically copy the whole thing here, and I'm going to change one thing. We're not going to call calculate bitwise calculate tile. We're going to create a new thing here. Let's delete this, and we're going to create a new static void bitwise see what I called that before. I called that calculate tile. We're gonna calculate inner tiles. That's a good word for that. And we go it's basically gonna use the same inputs here, I think. So we're gonna go like that. And it's gonna be, we're gonna calculate the tile offset here. Terrain height multiplied by num tiles per row in tile set. So that's our offset basically. We're passing in the terrain height. And if it's 0, then we know it's gonna be on the first row in the tile set here. Right there. And if it's 1, it's gonna be this one. If it's 2, there, 3, there, 4, and 5. So all the 6 levels, depending on what you throw in here. Then we multiply by number of rows in the tile set. So if it's on row 1, you're gonna get the starting point right here. If it's row 5, it's gonna be the starting point right here in the tile set here when we are counting on forward. Okay, and I'm gonna go. Since the auto tile terrain function adds 1 to the tile set, it should draw. We find the tile we want in tile set and subtract 1 from the value, basically. And here's going to be a lot of if statements, and what we're doing is we are subtracting 1 from the value. That means if we want to draw tile 16, the tile set here, let's have a look here. If you want to draw tile 16 right here, we have to name it as 15 instead. So if we want to draw 16, then we're gonna say, hey, we're gonna draw 15 instead. So this is the comment here, what this means. Isomap get tile and isomap xy minus 1. We're gonna check all the values upwards. This is inner tiles up. We want to check layer. See if we run this now quickly here before we do anything else. We can take a print screen and show you. Go here, yeah. I'll print screen. And I'm gonna paste this guy in here. Here we go. As you can see here, we're gonna change all these 7s here. They're all spread out. So we need to, like, if this a 7 and a 15, or if it's like a 16 and 16 and so forth. So we have to add these different if statements to correct the tiles here. So, like, to fix this 7, we are going to check if there's an 8 or a 16 there neighboring to it. So there's going to be 4 if statements for all the tiles, basically. So if this is up, and plus the tile offset, and the tile and isomap get tile isomap x minus 1. So first we are checking upwards, and then we're going to check to the right. Sorry, to the left, x minus 1, and map. X and y layer, of course. That equals to 7. 7 plus the tile offset. We're going to return. We want to draw the tile 8 instead, which is going to be in this turn going to be tile 9. So if we have a look at this first if statement, we're going to check up. If up is 8 and the tile to the left is a 7. Yeah, up is 8 and to the left is a 7. Then we're going to push in tile 8. So it's going to be this guy here instead. It's going to rewrite that value to become a slope that will fit nicely into this pocket right here. So I'm going to save you all the hassle by checking all the if statements. If you want to do that, you can do it and see why things are becoming what they're becoming. So I'm just going to add all the different tiles here. This tiles up. This is a good part that I've done it already, so I just gotta get things in here. Well, I don't know if that's like up or left. It should be like the top tiles up, and yeah, we can put in the comments in a few moments here, and you can add all these things here. It's gonna be a lot of else ifs all over the place. It's gonna be 14 here. It's gonna be 15, 13, 15, and 13 here. It's gonna be tile 18 instead. There you go. So 16 if statements for getting the inner tiles done. Eight, 4, 4, and 8. This is the boring part for you guys to watch, I guess. But we'll get this done pretty fast, I think. 14 and 14, and it's going to be 10, 12, 10 and 12. So we are looking up, and we are looking to the +1 here. We're gonna look downwards. So this is just gonna be up left, I think, depending on what because everything is like rotated here. So this direction up, and this is left. So we're checking up and left to make sure all these things are covered nicely there. Then we're going to check up and to the right, which is this corner here, and then down, right, and down left. So it's because it's rotated in that way. So goes up left, and it's going to be up right, and there's going to be down, and these are going to the minus. This is down left, and then we're gonna have down right. And if none of those are applicable, we can just go and return -1 here. Just gonna make sure that this will compile as well. That I have not done too many. Oh man, I missed something really essential here. If the if statement is okay. Oh yeah, that's a problem. Just gonna replace all of those with a simple curly bracket there, curly braces. Ah, cool. Boring editing. But we can just go and say that the spacebar and one of those guys going to be replaced with a semicolon. That we go. Oh, that was easier. Build, return with a value. Yep, it's going to be int, of course. No. Okay, my little girl asked, "If it's my turn to play now?" I was like, "Yep, you can go and play now." You're playing some mobile game, so they have to take turns. All right, build. Nice. So auto tile terrain is there, and auto tile inner corners. So now paint tile is gonna be equals to. I have no clue why that built. Like that looks really weird. That even this build was okay because I'm just throwing in some nice values there. Well, it has to be this guy here, like so, and go build again. And hopefully, auto tile inner corner tiles now. It's gonna be cold right here after we have performed our stuff here. Inside of this guy here. Oh, we can just for and then we go auto tile inner corners for the iso map and the layers here. So let's see if this guy works. Hopefully, I have not messed up too badly. And I did mess up somewhere, so I'm gonna have a look at the values, but it's starting to look okay up here. So far, but you can see here I missed like the values here. These guys are not being changed. So let's have a quick look at that. What I messed up, which value I did not change properly here. And the value did not change properly is this guy here. This should be plus. All right, so I think that should be it. And oh, come on. It's like this really annoying thing that if you get on the resize of the window is going to be annoying. But here you go. Here are the tiles being drawn on screen. Here comes a little guy walking on them. So this is what it looks like. And what we're going to do now is we're going to remove all those numbers from the screen because we don't want to have them at the final result here. So let's throw in, overwrite these guys here. Yes, please. Export. Okay. Let's have a look at this, build and run. And now, here's the tiles. But there's just one thing now, we have not increased the screen, really. The map size. So what we can do is you can quickly do that. And we're also going to increase, I think the renderer here needs another 80 pixels to be a correct resolution. Just a small minor thing basically. This should be 1280 multiplied by 720, like so. And we're gonna change the window height and window width as well. And I think that's just defined right straight into this guy here. At the top, what we have here, not sure. Yeah, map height. So you can say the map is going to be 640 by 640. And now we're going to have a much bigger map to scroll around on and look at here. But there's going to be one thing they're going to notice now, and that is we have some artifacts here at the edges. These guys here, for example. And some more guys here. This doesn't look too pretty, right? But it's only the outermost edge of the map all around. So we can go down here and have a look as well. Same artifacts here as well. Here as well. So instead of writing like a ton of if statements to solve this, like all these small little issues, there's a much more simpler way, and that is just to simply say, hey, let's just remove the outer rim of the map, basically. So no matter what we throw in there, it's going to be different. But before we do that, I can just show you can tweak the values a bit for the map when you're generating it. So for example here, we have the, it's going to look for new map thing here. Okay, map height 2, and tiles like 64. Yeah, here we're gonna change our implementation here, and we're gonna throw in, because right now we just hard coded here that it's gonna be 20 here. So what we're gonna do is we're gonna throw in the Perlin seed here as well, and Perlin seed and int terrain level, or right, terrain height, like so. Let's see, here we go to this guy here, and like so. I'm gonna change that in our things here as well. We're still gonna keep our map here. I'm gonna say let's do with seed 0. Our terrain height gonna be 20 for the moment. That's what we have, and we're gonna go back to the sorry about that. We're gonna go to isomap here, and we're gonna add these values in here instead. We're gonna pop them in right here. It's gonna be the Perlin seed, and this is gonna be the terrain height, like so. And if we go build, just make sure I didn't mess things up. Good. And now we're gonna change this as well from 20 to 10. And now I'm gonna show you, this is the terrain height, what happens. And here we go. So you can see now there's gonna be a lot more terrain all over the place here. So it's like gonna be mountains and things all over the map now. This is what it looks like. So it's like everything is connected. It's those nice things you get. And you're gonna go, and if we increase this to like 15, it's gonna be less of, it's gonna be more ground and less of these mountains. So you can see like more space around everything. So that's what's happening is that we are capping the terrain height. We're saying the higher we go, like if we give this like a value of 50, we're hardly at all going to have any mountain tops, I think. There we go, building one again. We're going to have some very small islands here. See this guy here. And now this is where artifacts are coming in as well. You can see this guy here now, because we are doing things so small that the current algorithm will not be able to fix these little issues here that we see right now. Either we have to add more if statements or other tiles in order to handle this small terrain here, as you can see. So once you get over a certain value, you have to mess around with more if statements and stuff like that to get the terrain to look good. So if we go to like 40, I'm not sure we can handle that either. We'll look at this. 40 is still like you can't really say that this is hills either. Like the guy is so small. Okay, this is a hill. It's like, yeah, the hill is only gonna be like super small. So yeah, it's better. You can mess around more with this if you want to. See, these guys here are all messed up and crazy. So a good value that I think 30 might be doable. So have a look at that. Not even 30 is doable. Well, it looks a little bit cool, but yeah, we're gonna miss a few values anyway. But perhaps 25 is like the lowest region we can get to. So auto tiling is gonna work for most part, but not on this guy. Even 25 was too big. So we need to have at least a little bit of space in between the stuff here. So this is somewhat okay. We have like a small artifact here. So we can add more if statements to, you know, to handle special cases like this. But what I'm using is, I'm setting things at 20 here. and we can use some other random number here, whatever, and build and run and have a look at the map. So now this is 20. It's like a bit. This is like big and chunky and nice. And it works for the auto tiling here, because we're doing different levels of stuff here. So, and it's still a lot of space in between. So it depends on how many hills you want. Those are kind of nice formation here. Yeah. I don't know if 25 is doable. We can have a look at that as well real quickly, and I think that could be doable. Oh, we get the artifacts here. Anyway, we can add more if statements to fix those small things. There's like, if you go 25, there's a lot of empty space all around here, but I don't really know where the limit is for the current generation for the terrain, but this should be awesome. 22 might be doable. Looks like it. Yeah, 22 is doable. And you don't get a lot of too much terrain either. Okay, it's not doable. We get some small artifacts there. So keep this as 20. It's like that's the limit for the now. If you want to fix that and add more if statements to correct that, it's up to you. But I'm happy with keeping it at 20 and getting my results okay. Hey, not even 20 was okay for this map. It was nice to see. So there's probably like a few more if statements to add to get this thing proper and done. Or I might have missed one, but we can have a look at this. This seems to be like a common one, so let's just change. We can do this in the tutorial here quickly. And we're gonna add the numbers so we know which tiles that are neighboring. Just seems to be one little statement thing to add, and we can zoom in on that here somewhere. That's when we are drawing things downward. So take a print screen on that, and we're gonna push it in here as well. So this means that we are looking down, and we can have a look. It's like when there's 10 and 10 down, and even 10 and 12. So there's two of those that we need to fix. We can say about 20 minutes, okay? In 20 minutes you can play. Well, in 20 minutes you can play, that's okay. I'm gonna continue my tutorial here, okay? Tell mommy. Go ask mommy. Okay. Yeah, they're so cute. They're coming and they want my attention and they want, I want my turn to play now. When is my turn? So, yeah. Well, anyway, we're gonna fix this now here, and it's just 10 and you need to know which tile to put in here as well. And I think we need to put in 17. Looks like the right tile there. So I'll be taking a quick break here just to get these things in, and you don't have to look for all of it. Okay, so I've identified a couple of slopes here that we need to take care of. And a static void. I go to correct minor errors and slopes. Nice map T is a map. So let's get ourselves a copy of this guy up here. Just gonna loop over all these things here. We also have the loop over the layers. equals 0. Layer up to isomap. Num layers. Why are you not getting myself a nice? Great. I hate this when intelligence just drops off for you. To the terrain height, the tile height here. Tile equals 0, tile height is gonna go up to tiles per row, and tiles per layer, sorry. And we go plus plus. Come on. There you go. There's going to be some quick fixes here. So I'm basically just going to do a copy and paste here of all the values I found. So you don't have to see me type all these things all over the place here. It's not tiles per row, it should be per tile set. I got that wrong there. So okay, come on. Oh, there you go. So let's have a build here and see if this guy is behaving. Okay, that's why. Okay, good. And let's see if this guy will now be happy. So, you know, it's gonna be all these special cases here to put in those tiles. So instead of instead of me boring you to death with that, we can just try this guy out now. On the tile terrain, and we get the slopes done, and we're gonna do some correct minor error in the slopes, and we're gonna do that on the isomap here. And let's see if it does what it should be doing. Get this guy over here. And here you go. It's filling in the blanks rather nicely now. Sweet. So there's just one thing left to do, and that is just to delete everything at the edges that we don't want to have there. So we can actually quickly try to increase this guy here to like 30 and see if it can handle 30 now. That would be nice if it does. Looking good there. Well, 30 won't be able to handle 30, so how about 25? So you really gotta try things out and see where the okay, it's doing some strange things there as well. So 30 is not doable. Let's keep it at 20 and be glad that you can generate terrain. Basically, in that sense, we can do more tweaking and fixing and playing around. So you can go as low as 6 or 7, and it's gonna be terrain all over the place. That's super hilly. like that. So it gets really confusing with all the numbers on, so we can remove those as well. But I'm gonna keep this as like 15. See if I'm happy with that before I'm gonna put an end to the tutorial here. That's a bit too much, I think. So I think 20 is a good setting for hills if you want to use that. And the final thing is to delete tiles at the edges, basically. So there's a lot of things going on. Whoops. Jumped away from my source code here. Give me my ISO map. Okay. And it's gonna be like static void delete tiles at edges, at map edges. This map T, ISO map. I'm gonna loop over this as well. We like our looping. And we're not gonna need the paint tile or the terrain height now. We're just gonna move over the loop over the map. And we're gonna have a layer instead here. Layer up to isomap num layers. Here we go. If we're at the edges, or if x is equals to iso map dot map width -1, or if y is equal to iso map height -1, then we know we want to do a simple isomap set tile. I'm gonna say isomap xy layer, and we're just gonna put the like minus whatever, -100. What are we initializing the map with? Let's see here. We're doing a mem set here. -1, well, it will be doable, I guess. Let's see what we get if we run this guy now. If. Oh yeah, we can't go if and if. Here we go. Build. Yeah, I'm gonna use this guy as well. And finally we will delete tiles at the edges, and then we're just gonna draw the tile. Sorry, draw the map. So as you can see now, the character is... Did we really delete them? I think we did. Okay, that looks really weird. It's like we did not do things correctly here. Yeah, we are deleting the tiles, but they're being drawn. Okay, the ground is being drawn as well, so we should just delete. There we go. It's gonna delete after we draw the green grass. Then everything's gonna look good. There you go. That's where we had a nice little artifact. Okay, so now things are looking good at the edges as well. So we're generating a map, getting things running smoothly. I'm gonna remove these guys here. We don't want to have the numbers anymore. I'm gonna go overwrite our item tiles there, replace, export, and let's have a look at this again. Nice. So we are now doing some Generation. Terrain generation here. Generating the terrain. So I think that concludes the tutorial here. It's been a nice one to record. Hopefully you will enjoy it as well. Playing around with it in the way you please. Okay. So thank you guys for watching and I hope you'll enjoy. Bye bye until the next tutorial.